Hi, I'm John, and that is me working on Scarlet the Four-Eyed Cuda in my garage. Today we are going to cover, hopefully, one of the last episodes for the data logger project that I've been working on. So I've got it pretty much worked together. It's all working on my desk, and so let's go through it. So this is the 3D printed case and SD card holder I made. You can see, I know there's a lot of glare off of it, but that's because of flaring from the camera. It actually looks pretty good in real life, but bear with me. But I'm doing this so you can at least see that the numbers are there and they are fluctuating. The temperature is accurate for being Florida in my house, and so that's pretty good. Yeah, I've got these connected up with these ethanol Deutsch connectors on for either side, and because of just the number of inputs, I needed multiple connectors, and then this guy is going to be for power. And right now I just have a quick disconnect on it so I can hook it up to a wall wart to test. So you can see I've got my drivers and passenger wideband O2 sensors. I've got pressure sensors for fuel, oil, and trans, temp sensors for oil, trans, and coolant, ambient, humidity, and temperature, engine RPM. I decided to make it green for just on the count of because. Throttle position sensor, I have it grounded right now so it stays 0, otherwise it would be floating around with variable numbers just like the O2 sensors are, because there's nothing hooked up to those pins. And then I've got the volts. I've got a 12 volt wall wart plug coming in, so that's fairly accurate. And then the vacuum, I've got 2 map sensors. One that'll be for the manifold, one will be for atmosphere. You subtract the two to convert millibars into inches of mercury for vacuum, and that gives me my delta and the conversion. So that's what that looks like. So let's open her up so I can show you what's in the middle. So we'll turn this off first, turn that off, flip it over, and these are just awesome little connectors. A little bit of a twist and pull up, and they just come right out. This guy's a little different, but same concept. It's got a little locking ring on it. And pull that out. These are 70 millimeter long M3 stainless steel screws. Come on. And then the screws that hold the connectors in are M5. I think they're 8 millimeter long, if I remember right. So I have the case 3D printed in 3 different pieces. I did the design with help from a buddy of mine in Fusion 360 using the free version. It took me a little while to get the concept of it, but with his help I was able to grab it and run, and we were all set. Took me about a week and a half to print it out or get it the way I wanted it, get the holes lined up and get the SD card hole lined up. So it wasn't specifically hard, just more time consuming. I did print out probably a dozen or so different pieces in tests. So this is it open. So let's do that. Sorry for the scratchy noises. It's not wanting to slide around on my desk, so we'll do it that way. So I've got the power coming in. The power goes into some lever connectors because I needed multiple ins and outs to take that power. So I've got 3 buck converters. Actually, I guess they're buck boost converters. One I have set to 12 volts, one I have set to 8 volts, and one I have set to 5 volts. And I used my multimeter to set that, and it's got these little trim pots right here, these little brass things that I'm pointing to with my finger. That has a screwdriver blade adapter to it, so you can just give it a little tweak and you can adjust the voltage coming out of it. This is the Mega Arduino. In the Pro package, it's designed to be integrated into systems versus what you've been used to looking at, which is this, which is the standalone version, more set up for breadboards and connectors to hook that up. So now it's more integrated. Now I have it soldered up, my SD card, my real-time clock. This is the Coil X. It has the 2 wires going to the coil and ground, engine ground, and then the 3 wires for voltage signal and ground. These are the connectors going to the screen. So you have 2 for plus 12 volts, 2 for ground, and it just uses TTL level serial connectivity. So it's just plus and minus. Then for the board itself, it's gone through multiple revisions. So let's start from where I started. So this is my first board that I did. You can see it has some product on it. This is the first version of the temperature sensor that I decided to use for temperature and humidity. I've got some resistors, capacitors. I had the hole sizes wrong on the PCB, so you can see my little green wire connectors are standing up and off the board, and I didn't like that. Found out that I made the holes too small. I put this guy on backwards, so that's why I have the connector, so I could turn it around to make it work. Basically, it was an epic fail, but it was my first time designing a PCB using KiCad, and I learned a whole lot, and then I took that learning and made what I call phase 2 of the project, which is the same thing, but with the hole sizes corrected. I corrected the pinout on the SD card, flipped it around because the way this was going to have to go, it was going to have to sandwich like that, which would make the board really thick between the space between the screen board and the other. So I know this isn't appropriate, but it would be more face to face versus stacked, yeah, if that makes sense. And after hooking up all the wires to these guys and moving them around and adjusting, I just did not like these little green connectors. They have a tendency to twist when you are tightening them down, and even though they are flush with the board, I can still wiggle them with my finger. You can't see it on the screen, but you can definitely feel it when you've got your finger on it and doing it. It was fine for the screen because it doesn't really do much, but for all the others, I just didn't like it. So I went from there to a board edge connector. And with the board edge connector, this was my first try with that, and it worked 100%. I really liked it because now I just have this one edge connector. You can see the board is a whole lot cleaner. There's between the number of parts, scattered all over the place to being all nice, clean in a row. And that's, you can see those edge connectors here. Put some pigtails. These are Deutsch connectors. These are Amphenol receptacles, and learned a little bit about those. Hooked those up. Works like a champ. Very happy with it. From a 3D printed, you can see this is, there's a little bit of a line there. And so you've got my 3 pieces. I made it in 3 pieces because of the screws. So the screws that I have holding the screen in place here, and these little black nylon screws that you might be able to see right about here. That's kind of hard to get into with all the other wires with this, 58 millimeter tall wall for this middle piece. So I made it 2 pieces so I could get to things easily. I'm going to have to reprint it. It's in 2 different colors for no reason other than it's just scrap filament that I had. I'm going to reprint it all in black so it matches the dashboard. But anyway, that's how the board design came. That's how the case came and its design, and it works. So the next time you see this, it may actually be on the car. I will be doing at least the temperature. So this is the coolant temperature sensor. And the Mopar Big Block has a spot for it. This exact size, it just has a plug in it by default. So just take the plug out, put this guy in. I've got Deutsch connectors, so I can just make this a quick connect off and on. So I've got the quick connect for this side, and then naturally there's a quick connect for the sensor itself, where it just lifts off like you guys would all know, and then it just pushes back on. Same with these. You just give it a squeeze, give it a pull, they come apart. They're IP68, I think, waterproof, so they should be great. And hook that up. Oil sensor, the driver's side of the block has an 1/8 inch NTP where the stock oil sensor goes. This one will go into the passenger side of the block where there's a 1/4 inch NTP. And then the top of this will be for the temperature sensor. So the oil temperature. So that'll just screw on there and I'll just connect it up. That's another reason why I put these 3 trim pots on here. So I put these temperature sensors are really thermistors, and a thermistor works off of resistance versus voltage. So you have to do a bunch of equations to convert that resistance value to a voltage value. And luckily, smarter people than me have done this, and it's called the Steinhart-Hart equation. And it's got base information, then it's got constants and floats and trigonometry and powers and logarithmics and such. It's all on Google availability, so you're all set that way. But the base of it is you have to take your normal resistance reading from your thermistor. So that's your baseline. And it effectively acts as a voltage divider. So this is one side of your resistor. You add a second resistor to be the other side of your voltage divider, and you're set. But this resistance has to match this resistance, the resistance on this guy, in order for it to really work. But because of manufacturing tolerances, every single one of these is different. So if you just swap this out, you're going to be plus or minus a couple of degrees temperature. So what I did is I put a base value for my resistor. I think this one was 2.2K because it measured like 2.6K of resistance. And then I put a 1000 ohm variable resistor. So I just turn that until the output from this circuit matches the resistance of this thermistor, and that locks it in. And as you can see from the previous screen, they're all within a degree or so of, which is probably just within the error factor of the sensor itself, between my air temp sensor, which is this guy, temp and humidity, and then the oil sensor, oil temperature and coolant sensor and transmission sensor. If you go back to the beginning of the video, you'll see that they're all in alignment with each other. So no major error factors there. So at this point, I just have to put this back together, put it in the engine compartment, and hook up these sensors and get it going. I believe it should work with 95% confidence. Everything should work. I did the short using the coil and doing the engine RPM, so that should be fairly good. Everything else should be fine. I have not tested a throttle position sensor because I don't have one, but I may have wanted to make sure the capability was there. And I have the AEM wideband O2 sensors, but I'm going to have to take the car to the shop in order to get the holes drilled and the bungs welded into the exhaust before I hook that up. So they're just going to be floating for a while because finances are really tight for me right now. But the rest of it should work without any problem. I might have some tweaking to do in the program itself. Right now I'm still calling it an alpha level. When I start making these tweaks, I'll upgrade it to beta and then go from there. Hopefully it'll be minor, but because of the loops and such and how often I'm pulling various things, when you actually have all of these sensors working and reporting at the same time, I might need to shorten or extend certain loops in order to get the values where I want them. As far as these connectors, just real quick, I really like these Deutsch connectors. If you haven't used them, they're amazingly easy to use. I can't think of anything else that I want to talk about on this, but I am very much open to questions. If you have questions on the project, whether it's 3D printing, whether it's the Arduino, whether it's the sensors and connectors I'm using, or whatever, please feel free to put those in the comments and like, share, and subscribe, and I would be very grateful. So thank you very much, and looking forward to getting this on the cart and moving forward. Thank you, and have a great day.